Welcome to qnawire.
Now we have, let's see here, we have a ideal Rankine cycle again. And let's see here, we have, um, we're given, it's basically the same as the previous problem, but now we're given some information. So we have very similar to this problem, but now we're given some information about the actual amount of heat that we're putting in, and that's 300 kilowatts. So what we can do here in this case is we know we had all of this stuff before from the previous problem, and now we can find H4 too because we know X4 and we know the pressure, and so we can find H4. And so the net work is roughly the turbine work if we're going to ignore what the work that we need to put into the pump is. So that's H3 minus H4, and that's 1,322 kilojoules per kilogram. And that means then we can also figure out the work in, um, and that is this minus this. So we can find the heat transfer, not the work in, the heat transfer in, because we have these. And now we know the power, the rate of heat flow in, we are given that. So then we know that, you know, Q dot in equals m dot times q little q in. So we know this and we know this, so we can find m dot, and that winds up being 0.0865 kilograms per second. And once we know that, we can get what we wanted. We wanted to find the power output of the plant. So that's the net work, which we have, times the mass flow rate. And that gives us 118 kilowatts. So we have, that is answer B.